Ouray Mountain Misfits here. Tim, Kelly's behind the camera. Today's a little bit on electrical, and I thought I'd start with the outside here. We're wiring the shop, and I want to talk to you about some of the things that might be important to somebody else who's doing a project like this, and let them know what some of the codes are and what we're doing, and hopefully it'll help somebody else. Our main service comes into our meter here, and from the meter it feeds to the house panel and to the shop panel. And this is 400 amp, 200 for the house, 200 for the shop. Code requires 2 grounding rods. We've got one here and then one here that are tied together in series. And those grounding rods are 8 feet long, and they're driven in the ground, which is quite a task, but they're required by code. And then this is the panel for our shop. You'll notice inside that it has a main disconnect, and that's important because if you don't take that into account when you're wiring the circuit breaker panel inside the shop or inside your shop or whatever you're wiring, it could cause you problems down the road. And this is the first point of disconnect. I'll explain why that's important once we get inside the shop. One other thing to note is we did put up lights. They're wired, I don't have any bulbs in them, and the panel inside the shop is not hot yet, so there's no power going to them, but we did get them installed. With the backer plates, we used pancake outlet boxes for the lights because there's only so much room there, and that allowed us to put those boxes in, secure them to the wall, and then wire out from that. And then here's the breaker panel, and you'll notice at the top of the breaker panel there's a space for 2 hots, a neutral. This is all labeled on your panel too when you buy the panel. A neutral, and then we'll put the ground in with the grounding bar here. This is a square D electrical panel. It was purchased at one of the big box stores. It's 200 amp service, and we bought it during COVID, so there was a very, very limited supply on what you could get. So this is what we ended up buying. And then all the circuit breakers in here, I went ahead and used square D also for the circuit breakers, just to keep it consistent. Although other brands will probably work in this panel, that's what we went with. And then keep in mind also, when you buy these panels, I know with square D, you don't get the grounding bus bar with it. You have to buy that separately and install that yourself, which is what we did here. And then the neutrals are here. And as I mentioned outside, that panel is the first point of disconnect for the power. In other words, that's the first location you can disconnect service for your breaker panel. This being the second point of disconnect, because it's got a main shutoff right here. The neutral bars and the grounding bar are separate. Inside the first point of disconnect, they're grounded together, they're tied in together, but from this point on, the ground bus bar and the neutrals have to be separate. And that's a big point, because if you don't do it that way, you may get some things to work, but anything that's metal in this whole system, including this box, will be energized. And all kinds of bad things can happen, like electrocution and fires and all kinds of different things. Also, with this panel, you get a number of things, and one is this grounding screw right here. If this had been the first point of disconnect, then this grounding screw would be installed here, and that would tie the neutral bars and the ground bar together. So because this is the second point and we don't want to do that, we leave that grounding screw out and then everything is taken care of. You'll notice here that we have these larger breakers, these wider breakers are 20 amp service, and code where we are requires that they be both ground fault and arc fault protected. So these are both ground fault and arc fault circuit interrupters, and that's to all of our 20 amp service. It would be all the electrical outlets. I just wired this one outlet in just to see how it was going to be, but all the outlets that go around the entire shop, plus we're going to put in a we're also going to put in a larger garage door opener, because this is an oversized garage door. It's heavy, it's insulated, takes a little bit bigger motor. That's also going to be 20 amp, and so that has to be ground fault and arc fault protected. Anytime you have a concrete floor, such as we do in this shop, then that GFCI and arc fault, it has to be part of what you do in your wiring. It's code where we live. It might be code most other places, I don't know, but for where we live, we had to use these arc fault and ground fault circuit breakers. And that brings up another point. When you're doing electrical, it's very, very expensive. The cost of this panel, the breakers, the wiring that goes out throughout the shop, you're between $1,500 $2,000, and that's doing it yourself. One thing I would suggest is the big box stores. It's quite convenient. You can go in there, you can pick out what you want, you can buy it and walk out the door, and it's immediate gratification. Go home and you use the parts. But if you go online and you check out the prices, here's a for instance. In the big box store, one of these breakers, just one, is $68. And if you go online, you can get them for about half that much, in the $30 range. And the same with the other type breakers, 30 amp and whatnot. I strongly suggest that you look around on the internet. If you wait 4 or 5 days, you can have what you need in the mail, and you can get going on your project. The wiring itself in the big box stores has come down dramatically over the last year. Dramatically by, in some cases, it's less than half that it was at its peak during COVID. So this is one option that you can use the big box store, and it's probably okay. But anything to do with circuit breakers and that type of stuff, I would definitely look online, and you can save yourself a bunch of money. We have a 30 amp service here that goes to this outlet, which is going to be specifically just for our welder. And then we have another 30 amp that's going to be wired for just our upright air compressor, so that we have those two separate. And then you have to keep 4 feet, and it can be any combination of that on both sides of the breaker panel. So from here to here is 4 feet. You can't have anything closer than that to the panel. You can have it closer, but you have to have that 4 foot clearance combined for both sides of the circuit breaker panel. And then we did our wiring for all of our outlets at an elevated height, because we're going to have benches all along this area here. All wiring coming into the breaker panel has to be retained with a clip or a staple no further than 12 inches from the panel, so keep all that stuff nice and tidy up close. And then the punch outs up here with these retaining clips, if you're doing 15 amp, which would be white wiring, it's 14.2 with a dedicated ground. You can have as many as 3 wires going through one retainer clip. I didn't do that because we just don't have that many circuit breakers here. We've got a total of 10. So I kept them all separate, and I labeled everything that I did. And then the 12-2, which is 20 amp with a dedicated ground, you can run as many as 2 through each clip. Again, I didn't do that because I like to keep them separate if I'm not running that many circuits in a panel. One other thing to keep in mind is that you have to decide where your main service is going to come in to your panel. And if you looked at the location where we have our main panel outside, it's almost directly behind this. So I think what I'm going to do is I'm just going to bring service, because it's directly to the lugs here, I'm going to bring service just through the top here. You could also bring it through the bottom. It's set up to do that, or the side for that matter, but we have 2x4s there. So the service is going to come through the top and connect in here and then to the ground bar, and everything should be nice and neat. When it comes to that major wiring off of the hot service box outside, I'm not an electrician. Kelly and I have experience doing wiring in houses and that type of thing, but I'm going to have an electrician do that because I just feel safer with that being done. Time out. And then the wiring itself, don't go stingy on the clips. You want to have a staple. I use these plastic staples because they're easier on the wiring, and you can see there's a little play in it. You never want to crush any of this jacket or the insulation on the inside of this wiring cable. You never want to crush that, because then you create a situation where you could have a fault. You could have arcing between the wires, which is dangerous, and the fact that that can cause a fire, and you don't want to burn your place down. These are just to hold these staples are just to hold these wires in place. They're not to crush them and hold them there, you know, real rigid. As a matter of fact, you don't want to tighten these down on this wire here to where it crushes the outside of the wiring or the insulation on the inside. It's just to hold stuff in place. And the clips, you want to have them about 4 feet apart. In some areas you're going to have them closer than that, but on longer runs you want to have them at least one every 4 feet. We're going to be putting in some lights. The cans are in the ceiling throughout the shop. These lights on the far left here, these will all be dedicated for the bench area and cabinets and that kind of thing. Then we'll have 2 runs in the center and 1 on the east side of our shop. And we're going to use low voltage LED lighting, which is all 14-2 cable, coaxial, whatever you want to call it. It's all 14-2, and all those are run on this side. Again, dedicated ground bar. When it comes to these lugs here, I don't know about every place in the country, but in a lot of counties they only allow you to put 1 wire per lug, and that was my experience in past wiring that we did. When it was inspected, that's what they required, and so I just kept it simple and I put 1 per lug. The same over here for the 20 amp, the neutral bar, just 1 wire per lug here. It's just a better way to go. That way you don't have any issues with inspections. You don't have any issues with wiring being exposed and potential grounding issues and that kind of thing. And then I actually like to keep my panels super neat, so I went ahead and I used these zip ties that were rated for electrical panels, and I pulled the wires together and I zip tied them. And you don't want to over tighten those either. I realize this is just a plastic band here, but zip tie them. It's just to hold them in position so that they are out of the way and they're uniform and they're easy to work with that way. And then you'll also notice on all the black wires, which are hot, I used a little bit of the insulation off of the cable, and I labeled everything. Like here, bench lights, center lights, east lights, and then the outside lights right here, which are the ones we showed you on the outside of the shop. And then over here on the 20 amp, I did the same thing. You know, we're talking about all these are going to be, except for one, which is the door opener right here. These are all just the wall outlets that go around the shop. And so I labeled all of those. We know exactly what they're to, and it's easy for me to see. And then when you take your panel and you're getting ready to finish up, all these numbers correspond to the slots over there where the breakers are. It's easy to label these because you've got everything labeled here, and then there's no confusion. It's really easy to do. Yeah, we still have some more work to do on the overhead stuff. Again, like I said, you want to have a staple, something securing the wire about every 4 feet. Obviously, it's not going to come down because it's above the rafters right there, but that just makes it, it secures it. You're going to be putting insulation on it. You're going to be putting drywall up or whatever you use for your ceiling, and that allows you to keep those wires away from screws going in if you're hanging drywall or anything else, and it keeps it out of the way, and it's also required by code, so you want to do that. And then over here, the way we wired it is when you walk in the shop, the main runs for the lights are going to be right here. So we'll have 2 light switches that'll operate these lights, and that'll be the lights directly above us, and then the 2 runs in the center of the shop. That'll be these switches right here, and these will operate these switches. And I can't emphasize this enough. You'll notice that I've got labeling on everything. I mean, all through the shop. If you do that, you're not going to get confused. You're going to know where everything goes, and you're going to be happier in the long run, especially when you get back to the service panel, because all of that stuff, you're going to have this spaghetti mess of wires hanging down, and you're going to want to be able to know where all those wires go, and so that's pretty important. I would say, when in doubt, just go ahead and label it. One last thing I want to mention here is, you see how the framing, these were panels that were brought in to build this shop. All the framing has all these angles and weird spaces and whatnot. It's super strong. It's all 2x6, and then at the top it's 2x8, I believe, sandwiched headers. This shop is just super crazy strong, great shear strength. It's a great way to go, but the issue is a couple of things. One is, you know, you're going to have to cut a lot when you hang insulation, so I'm looking forward to that, unless you use spray foam. And then the other was hanging this panel, because there was no place to hang it without cutting out a big portion of all this framing that's integral to what the walls are. So what I did is I created this wall, a faux wall in front of the shop wall that goes to the top, and these are 10-foot ceilings, and then I was able to hang the panels between 2x4s, and that allowed me the space to do the runs for the wires and hang the panel and all of that, and it also allows a lot of room in back for getting the wire through from the service panel outside to this breaker panel. But you want to think about all those things. Where are you going to hang your panel? Where is it convenient to do? If we put this panel, say, on another wall or another location, you're looking at, wow, the aluminum wire to run from the panel outside to this panel is very, very expensive. You could be adding, you know, hundreds and hundreds of dollars to the cost of your shop wiring just by having that panel in a different location. So that was thought out. That was something that we wanted to do that made sense for us. And moving forward, it's going to make anything else that we do that much easier. And if you'll notice here, we have all of this space and this space here. In the future, if there's something that comes up that we want to do as far as the wiring goes, we've got more than enough room to do that. But there you go. That's kind of an overview of what this shop is gonna be and how we're doing it. And hopefully in the not too distant future, we'll be moving a lot of stuff around or even out of the shop and get to a point where we can do some other things like the insulation. And I'm kind of anxious to do the drywall. I am going to use drywall. I think you know, before you might have been able to do it with OSB or even plywood, that kind of thing, but with the cost of materials anymore, OSB and plywood, I'd hate to think how much it would cost to do the inside of this shop. I think drywall is the way to go. You know, for $1,200–1,400, you can hang the drywall and get it ready to go, as opposed to, you know, I don't know, maybe the plywood might be, OSB would probably be around, I don't know, $3–4,000 for the materials. I think drywall will look good, and in the long run, we'll be happy with it, and it'll work for us. Anyway, that's it for now. Thanks for watching, and we'll see you in the near future.